Good evening, everyone. Today we are going to discuss about the R code for the principal component analysis and the factor analysis. So, in the previous lecture, we just talked about the Hotling T square and one example of principal component analysis. So now we are going to talk about the another example of the principal component analysis. So here we are going to take the data of the credit risk. All right. And we just check the principal component analysis on the correlation matrix. So in this one, we have the data of the income, debt, income we are taking, saving of the incomes we are going to take, and credit score we are going to consider, and that we are going to save in the debt underscore income, savings underscore income, and credit underscore score. So, and after that, we are going to define a data frame, okay, with the command data dot frame, where we are going to store the debt, income, and the savings of the incomes and the credit score under the data frame. So we just run it and we check what we are going to get. So this is our data frame here that we are going to get. So after that, we are going to apply the PCA, principal component analysis, on the given data set, where we are going to take the data 2 and in the PRCOM command, and center equals to true means we are going to centerize the data set, means we are going to subtract the each observation of each column by their respective mean. And scale is true, we are going to take here scale dot equals to true. It means we are going to standardize the each variable to mean 0 and variance 1 before applying the principal component analysis. So this is equivalent to performing the principal component analysis on the correlation matrix, that will ensuring all variables contributing equally. All right. So we are going to apply PCA here, and this is the output of our PCA principal component analysis. All right. Then we are going to call the summary here. Either you can call it like this, or you can call it the summary to explain the variance. All right. So PCA1 explains the 99.92% variance, and PC2 and PC3 explains the 0.06 and 0.01 respectively. Even after standardization, the three variables are extremely highly correlated. Basically, higher debt to the income tends to go with the lower savings and the lower credit score. And after that, we are going to check the loadings of the principal component here. All right. The PCA1 loadings are there. This is 0.577 and so on, minus 0.577 and minus 0.57720 and so on. So all loadings are about plus minus 0.577. That is basically equals to 1 upon square root of 3. So PCA1 is a constant, means it will explain that high debit to income tends to the positive contribution, and second thing is high savings to income and the high credit score tends to the negative contribution. All right. And after that, we will check the scores. Okay. PCA $X. So we are going to call that what is their basically PC1 scores. So negative scores here indicates that we are seeing some values are negative and some values are positive here. So negative value indicates the good credit worthiness, and positive scores indicate the poor credit worthiness. So basically means that, for instance, observation 1, depth is equals to 0.2, savings 0.3, and score 750 here. In this example, 0.2 is the debt, income and savings are 0.3, and credit score is 750. has the lowest score, most negative, and the best credit. This it will tend to the best credit. And observation for here with the debt income 0.6 and savings income 0.1 and credit score is 620. All right, has the highest score. Okay, that is the highest score 2.49. So it tends to the worst credit here. All right. So that is your example 3 here. Now we are going for the example 3 in the microeconomics indicators. So in this example, we have the GDP, okay, for 3.5, 2.0, and so on. Inflation, we are going to store as the 2.0, 3.5, and so on in a vector form. And unemployment, we are going to store, and this is the basically unemployment rate, that is basically 4.5, 6.0, 3.5, and so on. Interest, we are going to store again as a data vector 1.5, 2.5, 1.0, and so on. After that, again, we are going to store this as the data dot frame in the data frame. So we check it again. This is our data frame right now. All right. And then we check the apply the principal component analysis here on data 3, and center we are going to take true, and scale dot again we are going to take true. I already told you what is the meaning of the center and scale. So we apply here and we check it with the code. So this is the variation of the principal component 1, 4, 2, 3, and 4 here. So in the summary, we got the importance of the components. So here, the PCA1 explains the 99.48% of the variance, and other PCs are almost negligible. So thus, a single component capture almost all the variation among these macroeconomics indicators. So after that, we are going to check the shorted PC1 scores here. Right. And shorted like this. So this is the shorted one. So here, to interpret this one, we need the loadings. Uh, but so high GDP and low inflation and low unemployment and the interest indicate low interest indicates a healthy economy. So if a loading produce the high PCA1 for bad conditions, so then the ordering here basically D, that is the highest one. Okay, would mean D is the worst. In practice, we can multiply score by -1 to reverse the interpretation. After that, we are going to check the biplots here in the PCA. Biplots are very important to check it. Okay, so the interpretation of the biplot is like this. If I'm going to explain, so the horizontal axis in PC1, that is the most important direction of the variation. So the vertical axis is PC for the PC2, and this is for the PC1. All right, and countries are plotted as the number 1 to 5 here. 1, 2, 3, 4, and 5. Variables like GDP, inflation, unemployment, and interest rate that are shown as the red arrows. Okay, in which direction they are going. Okay, the two sets of axes, the bottom and the left are individuals, and top right for the variables. Okay, have different scales. not for the dual axis level. So how we are going to interpret this result? So GDP arrows point to the left, all right, along with the PC1, principal component 1. High GDP countries score low, basic negative on the PC1. Okay, they have the low PC1 with the negative sign, and inflation, unemployment, and the interest rate, all points are on the right side. Okay, and they are negatively correlated with GDP on PC1, and unemployment and the interest rate arrow are nearly parallel and overlapping basically here. These two variables are highly correlated with each other, and inflation has the slight downwards angle with PC2 and differentiating it slightly from unemployment here. Okay, so how we are going to interpret with the country's point of view? So country one, top on left. Okay, this one. This has the high GDP, low inflation, and unemployment. Basically, a strong economy they have, and three at the top left here has the high GDP but has a different PC2 profile, and country 4 on the right high. It is basically high inflation and unemployment, economically stressed, and country 2 and 5 here. These two clusters are near the center bottom, moderate economics. Okay, so this is the interpretation of your biplot in the principal component analysis. Now we will go for the another example, that is the pension fund returns. Here we will check the other things of our given data set. So in this one, pension fund returns, we have basically the stocks as a one variable, and we store the values of the stocks as a vector given here 5.2 minus 3.1 and so on, and the bonds here also stored in the vector, and real estates, commodities, all four variables we store in the basically in the vectors, and after that we are going to combine all of them in the data frame. Okay, I already explained you in the previous lecture why we are storing them in the data frame, why we are not storing them as a matrix. Okay, so we are going to run this one again, and data frame data 4 will be like this. So now again we are going to apply the PR component data at the data 4. Center is true means we are going to centralize the value, and scale dot equals to true means we are going to scaling them with the variance 1. Okay, and after that we are going to check the summary of principal component. This is the summary of the principal component. So PC1 explains the 89.65 variance of totals, and PC2 adds 5.76%, and cumulative 95.4% of two components. All right, and PC3 adds 4.41% and negligible additional, and similarly PC4 also completely negligible. After that we are going to check the loadings of this one with the command round PC4 dollar sign rotation at 1 to 2, and we are going to take the values after the decimal 3 up to the place 3 here. So we are going to print these values here. So these are the values of first two principal components. All right, so PC1 stocks real estate. PC1 is going to explain the stock real estate commodities have the similar negative loadings, almost 0 minus 0.5. Okay, and bond has the positive loading, that is 0.48. So PC1 contrast the risky asset, basically stock, real estate, and commodities against the bonds. So it tends to the flight to safety factor, and PC2 in the PC2 the bond dominates more with the value 0.867, followed by the stocks by 0.397. It will test to the possibly a journal market factor or bond market factor. All right. So after that, we are going to check the risk factors here for first two components, because remaining are not sharing the more that one. All right. So these are the scores. So here quarter 5, the stock values is minus 2, and bonds 2.5, and real estate 1, and commodities minus 0 point has the highest PC1 score, and PC score 2.60. Okay, the fifth one has the highest value, that is 2.60, and positive PC2 also with respect to that. High PC1 basically means high bond returns and low stocks returns, matching the data, high bonds and stock negatives. So after that, we are going to use the Biplot for the visualization here. So there again we have the Biplot visualization. So what it tells us, so bank A and bank B arrows are nearly identical here. Okay. And two banking stocks are almost perfectly correlated. They can almost be treated as one variable. And tag C and tag D basically are also nearly parallel and close to the bank's narrow suggestions. It suggests the technique tech stocks also move with the banks. All right. So basically, high market beta asset. So utility arrows point in a very different direction in the downwards. All right. So it tells us the utility stocks behavior diverge significantly from the bank and the tech stocks. All right. Sorry. Sorry. I just explained in the wrong manner. So stock and real estate and commodities all points left along with the PC1, and they move together. Basically, risk and asset. Their arrows are nearly identical and indicating very high mutual correlation. So bond point upper right is basically explain the bonds are negatively correlated with the other three assets, and this is the classic risk on the dynamic. So PC1 can be labeled the market risk factor, such that the positive PC1 will be equals to the safe or bond quarter, uh, and negative PC1 is basically equals to the risk asset quarter, and PC2 here separate bonds up from the basically up on side from the risk asset slightly differently across time. And how we are going to interpret this one? So quarter one upper left basically uh, risk the asset perform poorly and won't help us. So it will explain as the a flight to safety quarter, basically the market downturn, and quarter 5 here basically upper right, and it is explain the strong bonds and moderate overall, perhaps a rate cut environment. It will show that, and quarter 2 basically lower right. So it is tell us that the poor bond stocks also weak and rising rate environment, and quarter 6 here in the basically very low side, equity is very weak, and the risk of broadly. All right. So this is your fourth example. Now we are going to talk about the fifth example of this one. Here, this is the with the mortality rate. So, what is the mortality rate for the age 30, age 40, age 50, age 60 that we store, and after that we are going to make their data frame, and we are going to provide the data frame. This is our data frame. Now we are going to provide the row names of the data frame. Okay. Now we are going to run and check. So that is basically the mortality rate due to the smoke or non-smoke. So here, what is the rate of mortality rate of the male smokers for age 30, for age 40, for age 50, for age 60, and the mortality rate of non-smokers in male at age 30, age 40, age 50, and age 60, and female smokers mortality rate at age 30, 40, 50, and 60, and females non-smokers mortality rate at age 30, 40, 50, and 60 as given here. All right. So what we are going to do, we are going to apply the PCA here, and this time we are not going to scale it. Okay, and the command will remain same, and we will check what is going to be happen here. So this is the mortality summary of the principal component analysis. So here in this example, PC1 is explaining the 99.96% of the variance, and others principal components, principal 2, principal component 3, principal component 4 are almost negligible. This is because the mortality rates at different ages are highly correlated. All right. And we check the loadings here. So loadings are minus 0.093. Okay. And minus 0.178, minus 0.40, minus 0.89, and so on. So all loadings are negative with magnitude increasing with age. All right, if you just see, if you are going to take the magnitude of all of these values, so loadings are going to increase with respect to the age. So PC1 is the weighted sum of the mortality rate with the older ages given more weight. So because loadings are negative, a higher PC1 score corresponds to the lower mortality, since the larger mortality gives a more negative contribution and lowering the score. So thus PC1 can interpret as the inverse mortality index. So after that we are going to check the score of the mortality. Okay, that is 7.302.74 minus 1.60 and minus 8.44. So this is the score for the shorted score for the female non-smoker, male non-smoker, female smoker, and male smoker. So female non-smoker has the highest PC1 score. That means it has the lowest mortality, and male smokers has the lowest PC1 score, that will interpreted as the highest mortality. So this matches the expectation. Female non-smoker have the lowest mortality rates across all ages, and male smokers have the highest one. All right. So this is your fifth example. Now we are going to talk about the sixth example of this one. So we have the stock portfolio returns, okay, of the different banks: bank A, bank B, tax C, tax D, utility of E. and that we are going to store in the vectors. All right, and data 6 we are going to prepare a data set, and in that one we are going to store the values of bank A, bank B, tag C or tag D and utility like this, and we are going to apply the PCA principal component analysis. Okay, and we are going to take the scaling equals to true, and we are going to explain this one. Find out the summary. This is the summary of our principal components, 5 principal components. So PC1 explains the 93.34% of the variance. PC2 explains the 6.63% of the variance, and total 99.97% of two components with two components. So this is typically for stock returns. A single market factor captures the most co-movement. All right. Now we are going to check the loadings here. In the round, we are going to check the loadings of first two principal component, because first two components are sharing the 99.97% of the variance. So we don't need to call other remaining two principal components. So remaining three. So this is the values of the principal components. Basically scorings. So PC1 loadings are all are negative here. If you just see, okay, and nearly equals to 0.46 somehow. The first four, all right, rather than utility. Okay, that is slightly small. So thus PC1 is essentially the average return of all stocks with the negative sign, and it represents the market factor. And PC2, basically the utility, has the large negative value, that is minus 0.912. Others have small positive loadings. All right, that this is the difference or utilities from the rest, basically attached to a sector rotation factor. Okay, and we are going to check the Biplot market as factor. So all are on the negative side here. If you just see, so it shows that bank A and bank B arrows are nearly identical, and the two banking stocks are almost perfectly correlated. They can almost be treated as one variable, and tag C and tag D are also nearly parallel and close to bank arrows, and it will suggest the tag stocks are move with the bank, basically high market beta asset, and utility arrows point in the very different direction, downwards in the left. All right. So it explains the utility stocks behavior diverse significantly from the bank and stocks, and PC1 captures the shared market movement of the banks and the tech, and PC2 separates the utilities. All right, and PC1 captures. Sorry. So basically, the period 2 far right. Okay, period 2 and the period 4 on the far on the right, both had the high PC1 scores, strong bank tech performance. All right. And period 1 and period 5 on the left, 1 and the 5, they have the poor performance across the bank and the tech stocks. And period 5 on the left bottom, and the 6 on the top in the middle. So period 5, basically both market factors and the utilities negative. Basically it explains a broad downturn. And period 6, top on the center, it explains the moderate on both PCs and a stable period. All right. So this is your example 6. Now we will move to the example 7, that is the yield curve analysis. All right. So in that one, we have the yield. Okay. Yield 1 in the y1, y2, y5, y10 and y30. So different yields are there. Okay. That we are going to store in the data frame, and we will run it and we check our data frame, that is correct one. Now we will check the PCA on the principal component analysis on the yield. So again, the results are like this. It means only PC1 has the non-zero variance, that is 0.553 square, that will be almost 0.3, and others are essentially zero. This suggests the yields are nearly perfectly correlated. So in practice, we should say that yield curves have three main factors: level, slope or curvature, but the small sample size, 6 observations that we are having here, okay, in the data set, may limit the ability to capture the more than one factor here. So we will check the plot. In this plot, we have the maturities at 1, 2, 5, 10 and 30, and we are going to plot the maturities with respect to the PCA yield rotation, basically the loadings, with respect to the loadings, and type equals to B means lines should be there and with dotted, and y limit, the limit of the y-axis should be minus 0.8 to 0.8, and on the x-axis we have the maturities and y-axis we have the loadings, and the title of the plot will be yield curve factor loadings. So after that we are going to add the lines in our plot. So in that one we are going to add the lines of, basically, first will be in the first one lines maturity PCA1 yield rotation 2. Here we are going to have the levels, and in the second one we have the slope, and the third one will be the that one curvature. So we are going to, and we are going to differentiate all of three with the black, red and blue respectively. We are going to plot this one. So this is the plot that we got here of the level, slope and curvature. So the x-axis shows the bond maturities in a year 1, 2, 5, 10 and 30. And the y-axis shows the loadings, basically weight of the each maturity of each principal component. So three lines correspond to the three principal components: level, slope and the curvature here. So level factor PC1 is basically with the black line. So the loadings are approximately equal and positive across all maturities with the 0.5 approximate. Okay, 0.45 all the values. It means that PC1 shifts all the yields up or the down together. Basically, it's a parallel shift of the yield curve. This is called as the level factor. And second one, PC2, is the red one. All right. So loading start with the positive at short maturity, almost 0.5 here, and then drop sharply with the up to the negative side. Okay, at y equals to minus 0.5 to minus 0.10 side. All right. Then rise again for the 30y. Okay, for the 5, it will 5 to 10 year, it will be downwards, and then up to 30 again sharply it will increase. So this captures the steeping of the yield curve. Now the blue one is the curvature factor, the PC3, the loading from a curve. Basically, it shows that low at the short end, okay, and rising in the middle and creating the hump again. So this captures the curvature or butterfly shape. All right. So these three factors are foundations in the fixed income portfolio management. So in practice, roughly 90% of the field curve movements are explained by these levels and slope. This graph basically shows why three pieces suffice for the yield curve analysis. All right. Remaining we will do in the next lecture. Thank you.